here's my concave mirror again, and here's my tree, and here's my focal length. Let's get a little more specific. So this is not on the screen. This is my object. So whatever you're looking at, this is the object. And so the height of that object is the height of the object. That's from here to here. And the distance between the base of the object and I'm going to use a different color. The base of the object and the mirror, this is the distance to the object. That's this distance here. Now, I have the height of the object and the distance to the object. And now let's ray trace this out. Okay, so through the focus comes out parallel rays. Let's go through the center because that'll be a little easier. Through the center comes back out. So then here's where they cross. So this is where my little tree is, where my image sews up. This right here is my image. And this height from the principal axis to there is the height of my image. Hi. And the distance from my image, well, it should be right here to my plane of my mirror here, is the distance to the image. So I have kind of four variables: the height of my object, distance of my object relative to the mirror, height of my image, distance to the mirror. Now, let's take a look at drawing let's get rid of these lines, because I'm going to draw some more here in a second. There it all is. But now all the light from the top of my tree has to end up right here. So if I draw one that bounces off the middle of the mirror, that has to go, because I have already, has to go through the top of my image. Or if you do your math, you'll know that this angle, I measured that angle out. So go through there, go through that way. Oh, that totally, my pencil was off. Let's try that again. It's there to there. There it is. There, that's better. We know that this angle and this angle are the same. And now I have a height of an image that's distance away, height of an object that's this distance away, and they have the same. You have two triangles. Oh man, and they are similar triangles. So the height of the object, this over the height of the image, is equal to the distance to the object divided by the distance to the image. Those two are the same. However, notice this one's up and this one's upside down. So what we do is, to show that the image is upside down, in this code, put a negative inside of it. Are there any other ones that we can go on? Well, let's take a look at our picture again. So here's my tree. Here's my, let's see, here's the height of my object. Here's the distance to my object, and from there to there. Now where'd my image go? Let's draw it back out real quick. Well, or not, because I know exactly where it goes. If I could just find my green marker, this would all be much quicker. Or because there it is. It kind of hurts being red-green colorblind. All right, so there's my image. Let's draw the ray that goes through the focus. Now that's going to come out parallel. Oops. All right. But notice this height here, so there's this height of my image is also the height of my image here. And so the distance to this angle and this angle are the same. So now this distance is f. So let's see here. Let's height of the image over f is the same as the height of the object over, well, this distance here, which is SO minus F. But again, because we have that negative sign, the image is upside down. So now let's move this around a little bit. Let's do some rearranging, do some quick algebra. So now I end up with SO minus F over F equals HO over HI. That's a negative sign floating around over there. Oh, wait a second. There's a negative sign with that one. But I know from my previous that negative distance to the height of the object over height of the image is the distance to the object over the distance to the image. So this equals height of the distance to the image over distance to the object divided by the distance to the image. Now, what are we going to end up with? So SO minus F over F equals SO over SI. Now, if you want to do some algebra, you can, or as one of my favorite things to do, magic happens. And then you end up with 1 over distance to the image plus 1 over distance. 1 over distance to the object plus 1 over distance to the image is 1 over distance to the focal length. And this is your mirror equation. Distances to the images, SO or SI, can be negative when they're behind the mirror. So on our image here, notice this is a positive image, a positive distance, and a positive distance because they're on the same side of the mirror. When we had our other images, our virtual image from earlier, notice the light is coming this way and our image is behind the mirror. So this distance, this image distance, would be negative. So there you go. That is your mirror equation. A quick side note. Let me slide this up so we can get some bigger. This is also known as the magnification equation. Am I right over magnification? I ran out of space. So the magnification, M, is height of the image over height of the object. Notice that negative sign is not there because negative magnifications mean it's upside down.